Hello everyone, welcome back. Today let's see 3.4 zeros of polynomial functions. So in 3.3 we have learned if I have a polynomial function, for example, I borrow this space here, I have f of x equals a polynomial and it provides us 1 0, so 1 0, for example, x equals a question mark, and then we can list all the coefficients here and then put the question mark and then find the quotient. So the f of x equals the quotient multiplied by x minus this question mark. You must convert it to the divisor form. Then let it equal to 0. First factor equal to 0, second factor 0. We can find all the zeros for the function f. But now the question doesn't provide us the zeros. We need to find all the rational zeros and take a guess, maybe guess 1 zeros from these possible rational zeros. Let me introduce the rational zeros to you. Rational zeros theorem, we can find all possible rational zeros. Remember your P and S, they are, so P represents the factor of the constant term. The Q represents factor of the leading coefficient. So we can list all the possible zeros, then find the maybe take a guess from the possible zeros, possible rational zeros, then use the polynomial function. So use the synthetic division, find the factored form of the polynomial. Okay, let's look at the example. First one, the P. So the P is a factor of constant term. Oh, the constant term is -4. Find all the factors of -4. We know that -4 equals 1 times -4. And also -4 equals -1 times +4. We also know -4 equals 2 times -2. So that means the factor of -4, they are +1, -1, or +2 or -2, +4 or -4. Okay, that means I can list all the P on the top factor of the constant. They are +1 or -1, +2 or -2, +4 or -4. And the denominator, the bottom, is factor of leading coefficient. Leading coefficient here is 1. The factor of 1, let's see, 1 equals 1 times 1. 1 also equals -1 times -1. Okay, so 1 and -1, they are all the factor of 1. So we can put positive or -1 here. And then we need to see the ratio of this. So we can, so first we use positive -1 divided by positive -1. Then we're having positive or -1. And then we use different color. Second step, use positive or -2 divided by positive or -1. I'm having positive or -2. And then let me change another color. Let's use green. So we use positive -2 divided by positive -1. I'm having positive -4. So we got 3 possible rational zeros. Okay, let's see next example. Let's find all possible rational zeros for the function f of x. X equals all the factor of 6. That's the P. So we can find them. They are positive or -1, positive or -2, positive or -3, positive or -6. if you ask me why I didn't put positive or negative 4 there, because 4 is not a factor of 6. Okay, the bottom is the factor of leading coefficient 3. I can have positive or negative 1, positive or negative 3, because positive or negative 2 is not a factor of 3. You cannot say that 3 equals 2 times 3 half. So you say 2 is the factor. So 3 half is a factor. We do not say this. We only find the integers. The factor, they are integers. Okay, let's move on to see what is the ratio. So first I use, so I can use all of this divided by positive or negative 1. So I'm having positive or negative 1, positive or negative 2, positive or negative 3, positive or negative 6. And then use all of them on the top divided by, positive or negative 3. So positive or negative 1 divided by positive or negative 3 is positive or negative 1/3. And then we have positive or negative 2/3. Then positive or negative, so positive negative 3 or positive negative 3, that's positive negative 1. But it appears here. That means I don't need to list it here. Then use positive or negative 6 divided by positive negative 3. That's positive negative 2. But it appears here. We don't need to list it twice. So, so let's see, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We have 12 possible rational zeros here. Okay, let's see next example. First step, we need to list all possible rational zeros. Second, use synthetic division to test the possible rational zeros and find an actual zero. Number C, use quotient from part 2. Find the remaining zeros of polynomial function. Okay, let's follow the 3 steps. First, list all possible rational zeros. The x equals on the top. Find the factors of 12. They are positive or negative 1, positive or negative 2, positive or negative 3, positive or negative 4, positive or negative 6, positive or negative 12. Oh, we have a lot of factors of 12. And the bottom, so here is 1. So it's easy to find the factors. We only have positive or negative 1. So so all the possible rational zeros, they are positive or negative 1, positive or negative 2, positive or negative 3, positive or negative 4, positive or negative 6, positive or negative 12. Just to find the ratio, top and bottom. And then this is A, and what is the B? Use the synthetic division, test the possible rational zeros. Let's take a guess from all of these rational zeros. Maybe I can say, maybe x equals 1 is the rational zeros of the function f. I take a guess here. If I say x equals 1 is a 0, so what is the divisor for? So divisor for means x subtract or plus something equals 0. So from x equals 1, I can subtract 1 both sides. X minus 1 equals 0. Oh, sorry, equals 0. This is a divisor form. So let's use synthetic division, find the quotients. So let's put all the coefficients here in the What is this? Suddenly I forgot the name. Okay, so rectangle. So rectangle. So let's put 1, -2, -11, and 12 here. And then we put 1 here because I guess that maybe x equals 1 is my 0. Bring down the 1, take a, so do the multiplication outside. We have 1 here. And then addition, -2 plus 1, -1. Multiplication, 1 times -1, -1. And -11 plus -1 is -12. So do the multiplication, we have -12. Positive 12 plus -12 is 0. Yes, we found the 1 is the 0 of the polynomial f of x. So the quotient is x, here is 3, so x squared minus x minus 12. This is a quotient. The f of x can be written like the quotient squared minus x minus 12 times divisor x minus 1, because we said that divisor is x minus 1. So find all the zeros means we can say first factor equal to 0, second factor equal to 0. If the first factor can continue to be factored, so let's factor them completely. So we see x squared minus x minus 12. We can use AM method. Here's A, here's M. M is -12. Find 2 factors. Addition can make a -1, can make an A. They should be 3 and 4. Which one is negative? 4 is negative because addition can make a -1. So first part can be factored like x plus 3 times x minus 4 times x minus 1 equals 0. And then we can set first factor equal to 0, second equal to 0, third equal to 0. Then we have x plus 3 equals 0, x minus 4 equals 0, x minus 1 equals 0, minus 3 minus 3, x equals -3. Second equation, we add 4 both sides. X equals 4, comma. And then last equation, oh, why I put 1 here? I'm sorry, that's a typo. Plus 1 here. X equals 1. So we have 3 solutions, -3, 4, and 1. So these, okay, here, number 3, we're solving the functions zeros. So all of these 3 elements in the set, they are the zeros of the function f. Okay, let's see next example. Make sure I have enough space. Okay, first take a guess. Find all the rational zeros. X equals the p over q. P is all the factor of the 6. They are positive or -1, positive or -2, positive or -3, positive or -6. The denominator is the factor of 2. Factor of 2. Positive or -1, positive or -2. That's it. And then let's see the ratio. So we can ignore this one first. So take the ratio on the top and bottom now. They are positive or -1, positive or -2, positive or -3, positive or -6. And then ignore the first, so ignore this one. Find the ratio top and bottom. Positive or -1 divided by 2 is positive -1/2. Then positive or -1, because 2 over 2 is 1. But 1 appears here. I don't need to have this. So positive or -3 over positive or -2. It is positive -3/2. And then positive or -6 over positive or negative 2. That's positive or negative 3. But we see positive or negative 3 appears here. That means I can ignore that. Okay. Now we found the 1, 2, 3, 4, 5, 6. So we found 6. So we found 6. Oh, sorry, we found the 12 possible zeros. And then number B, we take a guess from the possible zeros, and then use synthetic division, find the quotients if the remainder is 0. Let's take a guess. Maybe we can start from the easy one. We say x equals 1. So the divisor form is x minus 1 equals 0, because we subtract 1 both sides. We make a right side is 0. Okay, let's see if I can find the remainder is 0. So write a rectangle and put all the coefficients inside. 2, -3, -11, +6. Put 1 here. Bring down the 1. No, sorry, bring down the 2. So multiplication got 2, and -3 plus 2 is -1. 1 times -1 is -1. -1 plus -11 plus -1 is -12. Do the multiplication. 1 times -12, -12. And then we got -6. Here, the remainder is not 0. So we failed. That means x equals 1 is not a 0 of the function. So let's take another guess. I'm going to guess. So let's take a guess. How about -2? So you can take a guess x equals -1, and then take a guess x equals 2, and x equals -2. Because I have solved this one before, I know the solution must be x equals -2. But maybe if we have time in the video, and also we have the space, we can take a guess that x equals -1. And then we do the same procedure. So write a rectangle and put all the coefficient here. 2, -3, -11, and 6. Put -1 here. Bring down the 2. We have 2. Do the multiplication. We have -2. -3 plus -2, -5. Do the multiplication. We have +5. -11 plus 5 is -6. And -1 times -6, +6. Remainder is not 0. It is 12. That means we need to keep on going to guess. Take a guess. X equals -2. And we list them in the rectangle. They are 2, -3, -11, and 6. Put the -2 here. Bring down the 2. We have 2 here. Do the multiplication. We have -4, -3 plus -4, -7. -2 times -7 is +14. -11 plus 14, that's +3. -2 times +3 is -6. Yes, finally we got 0. That's the remainder. Now the quotient part is 2x squared. I think that must be squared because here is a 3. So 2x squared minus 7x plus 3. This is a quotient. So the f of x can be written like the quotient times remainder. Quotient times divisor. 2x squared minus 7x plus 3. So now what is a divisor? We have talked about that we take a guess, x equals -2. Now rewrite it in the divisor form. So add 2 both sides, x plus 2 equals 0. The divisor is x plus 2. And then we need to solve each factor equal to 0. So the first one is not the factor completely form. That means I need to factor the first part. What method we are using? Maybe we can try the AC method because the leading coefficient is 2. So AC. So A, let me borrow some space, or we can. So let me borrow some space here. A times C equals 6, and find two factors. Addition can make a 7, negative 7. They must be 6 and 1, both of them negative. Then the addition can be negative 7. So let's rewrite the f of x. F of x equals 2x squared. Then split the negative 7x minus 6x minus x plus 3. The divisor x plus 2 is here. Then do the group factoring, first two, last twos. We have, so factor out the GCF from first two terms. They are 2x. Then the leftover is x minus 3. Last two terms, I must create the x minus 3 from last two terms. I can factor out the negative sign or negative 1. We have x minus 3 because you factor out negative 1, then you have positive x left. You factor out negative 1 from positive 3, you have minus 3 left. And then let's keep on going. Bring down the x plus 2. Then we factor out the GCF, x minus 3 times 2x minus 1 times x plus 2. We are looking for all zeros of the function. Let's list the three equations. X minus 3 equals 0, 2x minus 1 equals 0, x plus 2 equals 0. We can add 3 both sides, x equals 3. And then here, second equation, add 1, 2x equals 1, divided by 2 both sides, x equals 1/2. And then subtract by 2, x equals negative 2. So this one, we have 3 zeros. They are 3, 1/2, negative 2. All right, let's see next example. Number 13. Number 13, we also need to follow the steps. First, find all possible rational zeros. Okay, number A, x equals, the top, find all the factors of negative 6. They are positive or negative 1, positive or negative 2, positive or negative 3, positive or negative 6. The bottom is positive or negative 1. So all possible rational zeros, they are positive or negative 1, positive or negative 2, positive or negative 3, positive or negative 6. We have 12 options. Oh, sorry, not 12. This time we have 8 possible rational zeros. Number B, let's take a guess. We always start from the small numbers, easy one. Maybe I always guess x equals 1. So the divisor form is x minus 1 equals 0. And list all the coefficient in the rectangle here. 1, 4, negative 3, negative 6. And put the 1 here. Let's bring down the 1. 1. So do the multiplication. 1. 4 plus 1 is 5. And then 1 times 5, 5. Negative 3 plus 5 is positive 2. 1 times 2 is 2. Negative 6 plus 2, that's negative 4. Okay, here is not 0. That means we need to keep on looking for the rational zeros. Which one is a 0 for us? Since we have, so we can try x equals -1. Okay, the divisor form is add 1 both sides, make a 0 on the right. X plus 1 equals 0. So divisor is x plus 1. Let's take a guess. So put, it's not very beautiful. So let's do the synthetic division. 1, 4, -3, -6, and put -1 here. Bring down the 1. Do the multiplication. -1, 4 plus -1, +3. -1 times 3 is -3. -3 plus -3, -6. Take the multiplication. -1 times -6, +6. Yay, we got 0 here. That means the quotient is x squared plus 3x minus 6, because I know that the degree here is 3. Now we need to reduce 1 degree. So the f of x can be written like the quotient times divisor. X squared plus 3x minus 6 times divisor is x plus 1. So now we set this one equal to 0. We need to set the first equation equal to 0, second equal to 0. So first one, we may try the AM method, because here leading coefficient is 1. So we say A is 3, M is 6. And -6, find 2 factors. Addition can make a +3. We can say 1, 6, doesn't work. 2, 3, doesn't work, because 2, so one of them must be negative. If I make a 3 negative, we cannot make a +3. That means this method doesn't work. You cannot try the AC method, because if the AM method failed, the AC method also failed. So we must try some other method. This one, we know that the first factor, x squared plus 3x plus 6, minus 6 equals 0. So how to find the value of the x? We can use quadratic equation, quadratic formula. You remember that? If we have ax squared plus bx plus c equals 0, the quadratic formula is x equals -b plus or minus square root of b squared minus 4ac all over 2a. Oh, okay, let's see. A is 1, B is 3, C is -6. I can use quadratic formula. Oh, let's make a beautiful 6. So the quadratic formula is x equals -b is -3 plus or minus b squared minus 4ac is so is 3 squared minus 4 times 1 times -6 all over 2a, 2 times 1. Let's see, what is that? The bottom is 2. The top is -3 plus or minus. So that's 9 minus make a positive. And 4 times 1 times 6 is 24. Let's simplify this. That's -3 plus or minus 33 all over 2. Can I simplify this square root of 33? Or can I simplify this fraction? No. I have no way to simplify that. So this one are the 2 zeros of the function f. We cannot miss another factor, x plus 1 equals 0. Solve it, -1 here, x equals -1. That means we have 3 solutions or 3 rational zeros. First one is -3 plus square root of 33 over 2. Another one is -3 minus square root of 33 over 2. Last one is -1. Okay, ready to move on? Let's see, number 15. Number 15, let's see. Oh, last one is 23. Okay, first step, find all the rational zeros for the function f. X equals P over Q. P is all the factors of 2. They are positive or -1, positive or -2. The denominator is the factors, all the factors of 2. They are positive or -1, positive or -2. Let's see the ratios. So I ignore this one first. I will have positive or -1, positive or -2. Then I ignore this one. I'm having positive or -1/2, positive or -1, because we have positive or -1 here. So we have 6 positive rational zeros. Second step, take a guess and use synthetic division, find quotients. So I can guess, maybe I always start from 1. But when I'm doing this, I go back to see the function. I know the meaning of zeros. That means when I put the x equals 1 in the function, then the function equal to 0. Because if I have factored form equal to 0, x equals 1 means x minus 1 equal to 0. So this part equal to 0 make all the function equal to 0. If I plug it in the function x equals 1 in the function, if I can make it 0, so that must be the zeros for the f function. If I put all the positive value, so I pick some positive value from the possible rational zeros, then you see, here is positive, here is positive, here is positive. 2 is also positive. I cannot make any 0. So I cannot start to choose from negative. Oh, sorry. I cannot choose positive number from my possible rational zeros. I must choose some negative number. Then I could make a 0, make my function equal to 0. So this is not my good solution. Sorry, x equals 1 is a positive number. It's not my good option. So I can start from x equals -1. So make this function clear. So let's start from x equals -1, and then the divisor form is x plus 1 equals 0. Okay, let's write all the coefficient here. 2, 6, 5, 2. And then put 1 here, bring down the 2. So 2. Do the multiplication, we have -2. 6 plus -2, positive 4. -1 times 4 is -4. 5 plus -4 is 1. -1 times 1 is -1. 2 plus -1 is 1. Oh, we cannot make a 0 here. That means x equals 1 is not a 0 of the function f. Let's take another guess. Let's say x equals -2, because we can only pick negative number. The divisor form x plus 2 equals 0. Remember how to get the divisor form? We make the right side 0. Then draw a rectangle. They are the coefficient 2, 6, 5, 2. put -2 here, bring down the 2. 2 is here. -2 times 2, -4. 6 plus -4 is +2. -2 times +2, -4. 5 plus -4, 1. -2 times 1 is -2. Yes, we make a 0. That means -1 is a 0 of the function. So the quotient is x squared plus 2x plus 1. So the function can be written in the factored form, x squared plus 2x plus 1 times x plus 2. Okay. So, am I correct? Yes, because here is cubed. I must have squared. And oh, I know where is my problem. I didn't copy down the right quotient because here is 2. I couldn't miss my 2. All right, make it 0. And then first factor equal to 0, second factor equal to 0. First part, it is not a factor completely. Maybe we can try AC method or AM method, or if both method doesn't work, AC method we choose. If both method doesn't work, we must use quadratic formula. Okay, here is A, here is C. Maybe we can borrow some space here. A times C equals 2 times 1. That's 2. And then find 2 factors. Addition can make a 2 here. 1, 2. That's it. Or -1, -2. I tried many couples, but I cannot make a addition +2. That means I must use quadratic formula. So let's see. These 2 equations, 2x squared plus 2x plus 1 equals 0. And then another one is x plus 2 equal to 0. Then quadratic formula is x equals -b, -2 plus or minus square root of b squared, 2 squared, minus 4 AC, 4 times 2 times 1. Okay, let me make some more space. I think that's enough. Okay, the bottom is 2a, 2 times 2. Let's simplify this. So bottom one is 4, and the top is -2 plus or minus 4 minus 8. Oh, we are having complex number, not a real number. So look at the square root. We have square root of -4. So what is square root of -4? That is square root of 4 times -1. We can split the tops. X equals -4 plus or minus square root of 4 times square root of -1. Then continue to simplify the top. -2 plus or minus square root of 4 is 2. And then, so here I must remind you, we have learned the imaginary number I equals square root of -1. And then we put the I here. Now we do the simplification on the top and bottom. -2, so 2 here, divided by 2, top and bottom, we're having -1 plus or minus I. And then another side, another equation is much easier. -2 minus 2, x equals -2. Now, for the zeros of the f of x, we have 3 zeros. They are -1 plus I over 2, -1 minus I over 2, and another 0 is -2. Okay, let's see next one. This one, so the previous one is not very easy because we got a complex number. So if you want to write them in the pattern of complex number, because we know the complex number is a plus bi, and these two, they are not the 8x plus bi form. We can write them into, so split the tops. We have -1/2 plus 1/2 I. Another one is -1/2 minus 1/2 I, and another one is -2. So you make sure these two, they are a plus bi form. Okay, let's see. Let's move on. Number 23. Number 23 is a hard one because the degree of the polynomial is 4. So in previous question, the polynomial is 3, the degree, and this one could be a little hard. First, oh, well, I put B here. Okay, first step, we need to list all the possible rational zeros. So x equals, on the top, make a better division line. On the top, we need to find all the zeros, all the factors of 4. They are positive or -1, positive or -2, positive -4. The bottom is positive -1 because leading coefficient is 1. And then we can simplify all of the possible rational zeros. Positive or -1, positive or -2, positive or -4. Number B. So take a guess. What I'm guessing, I can take a guess. Start from x equals 1, x equals 2, or x equals -1, -2. And this time, let's try x equals, take a guess, x equals 2, because in previous one, we tried 1. And this time, let's start from 2. And the divisor form is x minus 2 equals 0. Okay, let's list all the coefficients in the rectangle. They are 1, -2, -5, +8, 4. We have a longer expression. Outside, we put 2 here and bring down the 1. We can put 1 here. 2 times 1 is 2. -2 plus +2 is 0. 2 times 0 is 0. -5 plus 0 is -5. 2 times -5 is -10. 8 plus -10 is -2. 2 times -2 is -4. Yay. We make a 0 here. Okay, let's write down the quotient. Quotient is x to the what power? Look at here. This is 4. Then the reduced one power is 3. X cubed plus 0 times x squared minus 5x minus 2. This is the quotient part. So the f of x can be written like the quotient x cubed plus because this term is 0, we can skip the second term, minus 5x minus 2 times x minus 2. Okay, have you learned that how to solve this one equal to 0? I haven't learned. Because we only learned ax squared plus bx plus c equals 0. We can try ACAM method and quadratic formula find the x, but this one is the power 3. that means we need to use the synthetic division again. Take a guess, all the rational zeros. And then use synthetic division, find the quotients. So if I'm listing two equations, x cubed minus 5x minus 2 equals 0, and then x minus 2 equal to 0. So a second equation is easy, x equals 2. But the first equation is hard to find the zeros. But we can say, I can make a g of x equals x cubed minus 5x minus 2, and then find the zeros from the g function, and then list all the zero in the set notation, including x equals 2. Or if you think, why you make a g of x here, you can ignore that. It's totally fine. Just to solve this one equal to 0, use synthetic division. Take a guess that we need to take a guess. We need to list all the possible rational zeros again for this polynomial equation. So the top, all the possible zeros of -2. So we can list positive or -1, positive or -2. The bottom is positive or -1. So we have positive or -1, positive -2. And then we can list the, oh, sorry, I haven't taken a guess. I feel this video is too long, so I'm a little bit tired, sorry. Okay, take a guess. I can say x equals positive or -1, positive or -2. Okay, maybe we can try positive, or maybe we'll try -1 first. Okay, now we need to apply the synthetic division to this equation. So list all the rationals, list all the coefficients here. 1, and what is the second term? I cannot say that's -5, because you see, you have one term missing. You must put 0 here to stay that position, and then -5, -2. Put -1 here, bring down 1, and then do the multiplication, -1. 0 plus -1, -1. -1 times -1, +1. -5 plus 1 is -4. -1 times -4 is +4. -2 plus 4 is, that's 2. It is not 1, not 0. That means x equals -1 is not a 0. Okay, let's try x equals -2. And then we have 1, 0, -5, -2. Put -2 here. Bring down the 1. -2 times 1 is -2. 0 plus -2, -2. -2 times -2, +4. -5 plus 4, that's -1. -2 times -1, +2. Yay, we make a 0 here. Okay, so the quotient is x squared minus 2x minus 1 equals 0. Then so this one can be factored as the quotient, quotient multiplied by the divisor. So we have x squared minus 2x minus 1 times x. So I didn't convert it to the divisor form. So x plus 2 equals 0. X plus 2. Okay, so we say this one equal to 0. That's the factored form of this. So let's solve this one. We have two factors. So first factor equal to 0, and second factor equal to 0. X squared minus 2x. Okay, So you may say, you didn't use the AC method and AM method. You didn't factor the first part completely. Yes, if you use AC method and AM method, I use AM method, so here is A, here is M. So M is multiplication, -1, find two factors. Addition can make a -2. So 1, I cannot make addition -2. That means I should use quadratic formula to solve the first factor. X squared minus 2x minus 1 equals 0. X plus 2 equals 0. So use quadratic formula. X equals negative b is 2. Negative 2 is positive 2. Plus or minus square root of b squared, -2 squared, minus 4ac, 4 times 1 times -1. Divided by 2 times a, 2 times 1. X equals 2 plus or minus square root of 4. Here is minus, here's minus. So we have plus 4 over 2. And then x equals 2 plus or minus square root of 8. Then x equals, we know that 8 equals 2 times 2 times 2. That's 2 squared times 2. So we can separate the radical sign. 2 plus or minus square root of 2 squared times square root of 2. X equals 2 plus or minus square root cancel, 2 square root of 2. Top and bottom can divide it by 2 at the same time. So is 1 plus or minus square root of 2. Yay, we found this. And then another equation, don't forget this, x equals -2 because you subtract 2 both sides. So we got 3 solutions here, but do you still remember that I mentioned we cannot forget another zeros on the top, x equals 2. That means we have 4 solutions. We must list them here. They are 1 plus square root of 2, 1 minus square root of 2, positive 2, and this one, -2. All right, we finished the chapter 3.4. If you have any question, please let me know. And enjoy the video. Have a good day. Bye-bye.